We're thrilled to have as a presenter for this morning's or this afternoon's, depending on your time zone, webinar, Gage Kingsbury. Gage has been with NWAA for a long time. I think Gage and I first met probably back in the late 80s at some time when NWAA was just kind of a small mom and pop collaborative trying to do new and exciting things. Gage, prior to that, had a history with Portland Public Schools in developing some adaptive opportunities for assessment. He's nationally and internationally known in the adaptive testing community, and many of you may well either know Gage personally or may have read some of his papers or seen him at various presentations. Gage is still part of NWEA, although in a relatively informal manner. He's sort of transitioning into retirement. Would that we could all do that, but anyway, he's lucky enough to be transitioning into retirement, so he's in a transition area where he's beginning to close out his responsibilities at NWA and has made himself available for us for this this webinar because the timing is so important for us to get a deeper and richer understanding of adaptive testing. So if this were a large group in a large crowd in a large hotel room somewhere, I would kind of anticipate that we get applause at this point. But Gage, I think I'm going to hand it over to you, absent applause, but please know that in hundreds of places across the country, individuals are applauding on their own, welcoming you to the webinar. So thank you, Gage, for helping us, and I'll hand it over to you.
And one quick note before we turn to Gage, just to note that to everyone, this webinar is being recorded. Thank you.
Thanks, Kate. Thanks, Joe. This is Gage. Hopefully everyone can hear me. Topic today is decisions to be made in developing an adaptive testing system for K-12 education, which sounds like it's probably a question that's in the forefront of many of your minds. Let's talk just a little bit about what adaptive testing is, and then I'll give you an opportunity to ask questions that you have, and I'll try to feed those into the rest of the conversation. So an adaptive test is a test that adjusts its characteristics based on the performance of a test taker. I use the term adaptive test because an adaptive test doesn't necessarily have to be a computer-based test, but 99.9% of them are. As a student is taking an adaptive test, he or she will see content of a difficulty that changes based on their performance. As they do better, the content will get more difficult. As they do not so well, the content will get easier. And the purpose for this is to provide a challenging test for every student that takes the test. And you folks already know that, so I thought I'd make that obvious. Before we get too far into the conversation, I thought I'd give you guys an opportunity to ask me any questions that you want using the Q&A slide. And so let's just take a couple minutes for you guys to type in questions related to adaptive testing, either the design of it or questions that you anticipate getting from your constituents in your states or from parents or from schools and school administrators. So let's take just a couple minutes and allow you guys to do that. Okay, and the stunned silence seems to indicate that I've beaten you all into submission, so you have no questions.
Gage, it's Christian. I see that in the chat there's one question. I don't know if you can see it above. It's not in the Q&A. That's regarding constraints.
Thanks, Christian. Yeah, I think the questions I'm getting so far are pretty good ones, but okay. Well, let's go on and get started. I'm going to start with Kelly Spurgeon's question, because I think she or he has asked a very interesting question, which is, does CAT always ensure a shorter testing duration or a smaller assessment footprint? So let's keep that one in mind as we move on here. Okay. Okay. Let me talk just a little bit about how an adaptive testing system works. As a student comes into a particular test they're taking at a particular time, the proctor for the test will assign them to the test they're going to take, and then the adaptive test will use either a generic starting point or past information about this particular student to start them off into a test at a certain level of difficulty. So, for instance, this individual started the test at a difficulty of 175. Which means our best guess at the beginning of the test is that the student is at 175 on our achievement scale, whatever it happens to be. And I'll be talking a lot about difficulty and achievement interchangeably, because one of the hallmarks of an adaptive test using IRT is that it puts the score for the individual on the same metric as the difficulty of the questions that are being administered, which has a couple of nice features. Okay, so the student gets the first 8 or 9 questions right, which indicates that our initial position for the student wasn't particularly good, so they moved from 175 to 191 until they got up a little bit closer to 230, and so they basically moved from the basic category through the proficient category into the bottom end of the advanced category. So the student is doing quite well. And as the student gets questions right, they get more difficult questions. When they start to answer questions incorrectly, the difficulty will vary throughout the length of the test. This is a particularly short test. So the two things that you might want to note from this slide, one of which the difficulty of the questions being asked is following the achievement, the performance, today's performance for this student. And the second thing is that the error of measurement represented by the bands is getting smaller and smaller and smaller as the student gets toward the end of the test. And in this case, you can see that the standard error of measurement is completely above the advanced line after about question 15. So that gives you an idea of how an adaptive test works. But let's talk a little bit about kind of the nature of an adaptive test and why people have wanted to do this. Adaptive testing has probably about a 100-year history, starting with Alfred Binet, and the test eventually became the Stanford Binet. Frederick Lord at ETS did a tremendous amount of research on adaptive testing, but never developed a computerized adaptive test. And that's predominantly because he was working in the 50s and the early 60s through the late 60s, working on models of adaptive testing that could be used in paper form, not thinking so much about computers, because at the time the average computer was the size of a room, and the average school or organization couldn't afford to have one. Okay. For those of you who came to the earlier webinar on adaptive testing, you heard a little bit about David Weiss. And David was probably the first person to build operational adaptive tests in any kind of substantial way. He did a lot of work for the armed services in the mid-70s. He developed a lot of the adaptive testing strategies that we use today, and more close to what we're talking about today. He developed the first adaptive achievement tests, and that's actually where I got to know him and started working on adaptive achievement testing. Okay, that's probably more than you wanted to know about the pioneers of adaptive testing. Most of the work they did was a little bit on the ivory tower side. It was working with theoretical models for adaptive tests. The first folks who actually implemented large-scale adaptive tests ran into a host of questions that you guys are addressing that the earlier researchers didn't really have to address, because they were working with college populations, and they were working with single testing centers, and they were working in very controlled environments. So the first implementers of adaptive testing included David Foster, who did work with Novell engineers in the IT world, Jim McBride, who did work with the Armed Services Vocational Aptitude Battery, Tony Zera, who did work with nursing licensure, and I got bold and put myself on the list because I was doing work on adaptive educational tests at about the same time. Let me take you into a different world just for a split second and introduce you to some of the work that Tony Zera was doing in the mid-'80s. By this time, we had personal computers available fairly easily, and so when Tony was starting to develop his nursing licensure exam as a computerized adaptive test, he was actually moving from a paper test to a computerized adaptive test, which began to have all sorts of interesting questions associated with it, like, does the adaptive test do as good a job as the paper and pencil test? Is it actually more efficient than a paper and pencil test? And the answer, at least in Tony's case, was yes and yes. They did a number of studies when they were looking at moving to an adaptive test, and identified that the scores were virtually identical on the average to the earlier tests they're using, and they changed a test that was given over 2 days to a test that is given in 1 hour. In 6 hours on 1 day, and so that was advantageous from the point of view of allowing folks to become nurses without having to take a licensure exam that took more than 1 day and took them away from their homes and families for in a lot of cases. Okay. Enough about people. Let's talk about stuff. You've chosen to use an adaptive test because it can be more efficient than a fixed form test. And let's get back to the question that was asked earlier, which is, does it always ensure a shorter testing duration or smaller assessment footprint? And you're in the place of kind of deciding that. If you look at the tests that are given in your state today, let's say they take 4 hours to complete. As you move to an adaptive test that's related to the Common Core standards, you have 2 things going on. You have a need to get a rigorous test in place that covers a broad array of content standards, and you also have the ability to allow adaptive testing to help make things more efficient. So whether or not that will result in a shorter testing duration kind of depends on the choices that are made. It's very possible that with the new content standards, attempting to measure all the content standards while using a variety of item types, you may find that the testing duration actually expands a little bit, even though the adaptive testing is pretty darn efficient. So it depends a lot on what decisions are made. If the decision is made to have a wide variety of item types, that requires more student time to get them familiar with the item types, and some of the item types may take longer than others for students to answer. So it isn't a given that adaptive testing will provide a shorter testing time, but it will always be more efficient than a fixed form test trying to measure the same content. Okay. Some other reasons you might want to use an adaptive test are that it provides good information across a broader spectrum of student performance. And one of the difficulties that we ran into when NCLB was put into place was that we ended up giving our teachers a little bit less information in some cases than we were before NCLB. Many of the states were using scale scores of one type or another prior to NCLB, and once NCLB went into place, they started to use categorizations of students. In one way, that's good, because if you put students into broad categories, it allows teachers to do grouping. It allows teachers to kind of aim the instruction at broad groups. The bad news is it's not quite as accurate for any individual student. And you folks all know, a student that is a point or two below the proficiency level and a student that is a point or two above the proficiency level are a lot closer in their learning, what they know and can do, than a student at the bottom of the proficiency level and a student at the top. So an adaptive test allows the capability of having additional information. I'm going to keep going so we don't get too far behind on time. One of the things I wanted to mention real briefly is that recently CAT has seen a tremendous growth in the international community, which is good. I mean, you guys are starting to do adaptive testing at a time in which it's a very popular thing to do. One of the things that was mentioned in my bio slide is that I'm currently working with the International Association for Computerized Adaptive Testing, and it's kind of a fledgling organization that's trying to provide information about adaptive tests to a wide range of folks in a wide range of countries. So the good news is that you've made a choice to move to adaptive testing at the same time that a wide variety of other folks are making that same choice. Some examples that are not education related. There are a lot of examples that are, but I chose to have some that were not education related. The Ravens matrices have turned into an adaptive test in Vienna. There's a test for written English for Spanish speakers. You get the general idea. There are probably 30 or 40 different international organizations doing adaptive testing in one way or another. Okay. One of the things that folks fairly consistently ask, and it's asked in our questions too, is how can you give a test where all of the students take different tests and give them scores that are in some way comparable? And that's a great question. It's a question I've gotten for the past, I don't know, 30 years. And the answer is kind of simple. To start with, an adaptive test gives students access to an entire item pool. And so the questions that a student sees from that item pool are based on the student's specific performance. So each student has access to every item in the item pool. The ones that they tend to see are related to how they perform within the item pool. That's kind of the nature of an adaptive test. But why does this give us comparable scores? And the reason that it gives us comparable scores is that we have some trust and we have some empirical evidence that our item response theory model that we're using works well. So whenever an adaptive test is being built, the first thing that has to be done, one of the first things that has to be done, is the building of a response model that makes sense. We'll get into that a little bit later. Let's just talk a little bit more about the accuracy of an adaptive test. One of the questions that's commonly asked is can you get the same results from an adaptive test that you can from a paper and pencil test? And the answer is commonly yes. There have been a substantial number of studies done, like the one I'm showing you now, that have compared, in this case, a paper and pencil test administered in the fall and the spring to a paper and pencil test and a CAT test administered in the fall and the spring. And what you can see is that the mean scores are virtually identical, and the relationship between the spring scores and the fall scores is virtually identical as you go through different levels of achievement. And that's kind of good news, but it doesn't really tell you the story about what the adaptive test is actually doing, because when we look at what the test is actually doing, it comes out a little bit like this. And this is the one slide that everybody on the planet who does chat workshops has to use. This is the information function, how much stuff you're getting from the test for a test that is an adaptive test at the top line, a test that is aimed at a fixed form test that is designed to be close to the mean of student performance, and another fixed form test that is designed to be close to the proficiency level, the red vertical line. Okay. And what you can see in this picture, and I just usually see when you're comparing a fixed form test to an adaptive test, is that the adaptive test provides more information throughout the range of student achievement. Okay. What's more important, and what you don't always see, is that in the extremes, students who are struggling, students who are excelling, you get substantially more information from the adaptive test than you do from either of the fixed form tests. And it kind of makes sense when you're developing a fixed form test that's associated with a proficiency level. What you end up doing is selecting a fair number of items near the proficiency level, and slightly fewer items a little further out, and slightly fewer items even farther out. And so when you get to the extreme performance levels, there isn't a huge amount that is of appropriate difficulty to challenge the students who are struggling or the students who are excelling substantially. So that's kind of an idea about one of the advantages of an adaptive test. In this case, the tests were all the same length. One question I'm commonly asked when I get to this slide is, why is it that even in the point at which the fixed form test is designed to serve well at the proficiency level, why is it that the adaptive test gives more information? And the answer is relatively simple. The fixed form test needs to include a little bit of content for the kids who are a little bit higher, much higher, a little bit lower, much lower. The adaptive test for a student near the proficiency level includes more content of a difficulty that is close to the proficiency level. So hopefully that makes sense to folks. Okay, let's get into the decisions that need to be made related to an adaptive test. And these will start to address some of the questions that I was asked earlier. First of all, you have to make psychometric decisions concerning the interface for the proctor, the interface for the students. You need to decide on what item designs will be used in the test. You need to decide what the test design itself will look like. A number of other things. You get the general idea. These are kind of the places that you will want to make a series of meaningful decisions. And the bad news is that a poor decision made in any of these places may cost students a lot. So you're in the very important phase of this effort because you're making these decisions now. Okay, so if we think about the basics of a theoretical adaptive test, we first identify an item response model that makes sense for use with our adaptive test. We will verify that item response model works well as we go through the field testing of items and start to get information back about how the test is performing. We figure out the characteristics of the item pool that we want, and those decisions can include things like what item types, how many items, how should they be spread out. We identify a process for selecting the first item for each student's test, which can be as simple as based on the last test that this student took, which item should we give them? Or it can be as simple as, based on the grade the student is in, what set of items shall we choose from randomly to give them an item? And from that point on in the adaptive test, we are checking to see whether we should terminate the test or select the next item. And selecting the next item can be done in a variety of ways. Terminating the test can be done either at a fixed test length or at a fixed amount of information or some more complex criterion for terminating the test. And then finally, we score the test itself. So those are the basics of a theoretical CAT. Unfortunately, you're not doing CAT in theory. You're forced to do CAT in operation. And let's start with some before the test decision areas. One question is, how will we develop the measurement scale? At this point, deciding which IRT model is part of that, but the mechanics, the engineering of the measurement scale are at least as important. So decisions to be made or decisions that have been made, a vertical scale across grades gives you some capacity to measure growth in ways that a scale that's designed within grade doesn't. What mix of item styles will be needed? Let's talk about that one just a little bit more. So I think that one's a useful one to talk about. The test is going to use a broad mix of item styles to help address the Common Core standards. And that's important to know because it provides requirements for professional development, for teachers, and familiarity exercises for the students, so that when a student addresses this test, he or she is not seeing an item style for the very first time. Give you a stupid example. One agency that I worked with wanted to introduce items in which more than one answer was correct. And they wanted the individuals taking the test to choose all that were correct. But because folks were very used to taking traditional multiple choice questions, even though the question said choose all that were correct, they chose the first one they saw that was correct as if it were a multiple choice question and moved on. So familiarity in a new item style and an understanding that this new item style will appear on the test is really important, both from the teacher's point of view and from the student's point of view. There's also a small caveat in using new item styles, which is they may induce undesired biases in the scores. For instance, if you're really interested in communication in mathematics, as an example, it's real easy to induce an unintended bias into the scores if you're using what amounts to a long reading passage to trigger a mathematics question. So while you want to use new item types, while you want to move into new item types, you want to do it in a way that's empirically sound. So as you start using new item types, you really want to make sure that the teachers and students are on board in terms of their familiarity, and make sure that the new item types that you're putting in place aren't having undesirable consequences. Let's leave that at that for right now. Okay. Let's talk just a little bit about IRT models. Someone asked a question about how IRT models influence item usage, which I think is a real good question. given the mix of item styles that are desirable for use in this test, it's probable that a single polytomous model can be used to put all the items onto a common measurement scale and allow them to be scored with a single scoring mechanism, which is really good. I mean, that's a good place to be. The item styles that have been chosen to date lend themselves well to a polytomous IRT model, and that's good because there's a lot of research that's been done on the polytomous models to put you in a position to use this type of model within the context of an adaptive test. And I'll give credit to some folks at the University of Texas for doing most of the work in using polytomous IRT models for adaptive testing. However, given that it seems like it will work, you have to go through the work of identifying whether it actually does work. So you need studies that identify whether a unidimensional model makes sense or whether you need a multidimensional model of some sort. You need studies that indicate that common stimulus items don't cause undesirable covariance. Let me give you a little bit more on that, just so it doesn't sound like gibberish. You have a number of questions that are associated with one reading passage. What you want in the system is that those items all contribute to the score for the individual as if they were relatively independent items. What you don't want is a passage that causes students to either miss all the questions or get all the questions right. And you know, in a way that has unexpected covariance between the item responses. Okay, and then the last point is just that you want to make sure that the multiple item styles don't induce a bias within groups. Okay. All right. A couple of the questions that are real important. One is the depth of the item pool. The depth that's needed in the item bank to choose the operational item pools. Commonly these days, you have an item bank that is N,000 questions, and you have an operational item pool that's in use at any one time that is a subset of those N,000 questions that are chosen for a particular purpose. And you want to make sure that you choose an operational item pool that has good content representation, good item style representation, good difficulty representation, and still has good depth. And the reason I mention that is that in the past, some folks have tried to use slightly smaller item pools to kickstart their adaptive test. And it's commonly not a good idea because this test is going to be kind of a modestly high stakes test. For education, it can probably be viewed as a very high stakes test. You know, for the world in general, excuse me, it's not real high stakes, but it's way higher stakes than most educational tests, and that opens up all sorts of interesting questions. We'll talk about security in a little bit. But first, I want to talk a little bit about what a test blueprint might look like and how it should be associated with an adaptive test that an individual student is taking. Commonly, since an adaptive test tends to choose items from a large item pool, The test blueprint looks a lot like a set of constraints. So a set of constraints associated with a particular test might include content weights. We want 30% of the test to come from this content area and the rest of the test to come from another content area. It might include minimum and maximum test lengths. Well, it should definitely include minimum and maximum test lengths. It can include time constraints. Those aren't commonly recommended in an adaptive test, but there are some limits that you kind of have to set. So setting a liberal time constraint gives you the advantage of having a fairly power test, a test that's closer to being a power test than it is to being a speeded test. And you want to err on the side of the test being a power test because as you move from a power test to a speeded test, a lot of the assumptions of item response theory tend to be a lot more difficult to maintain. Okay, getting back to the blueprint. You might have something built into the blueprint that suggests the item style weightings. So we want, 40% multiple choice questions and 20% short answer questions, and like that. So it's easy enough to include weightings associated with item styles. It's also fairly easy to include weightings that have to do with cognitive complexity. Cognitive complexity tends to be just a little trickier because cognitive complexity tends to be associated with the difficulty of the items. So I'd be a little careful about how I used cognitive complexity as an aspect of the test blueprint. The good thing about the Common Core standards is that they do a fairly good job of identifying the standards in a way that cognitive complexity is built into the standards, built into the content, rather than built into the tests. And then the last thing I wanted to mention just briefly is the handling of what are called enemy items or previously administered items. In a lot of cases, the item pool is so large that you may have 2 items in it or a number of items in it that you don't want to administer together. Obvious example, question 1 asks a question like, which of the following is a right triangle? And the second question asks a question like, which of these right triangles has the following perimeter? Okay, you may not want to ask those questions in the same individual's test, even though each of those questions may be, perfectly fine for use. Okay. What else do we have going on? I want to make sure that I address your questions as I'm going through. So, let's take one more opportunity to allow you guys to put in some questions. So if you're willing to type in questions at this point, I will go through the ones you already asked, see which ones I haven't addressed. I got one question from someone who says they lost audio. So hopefully that isn't a common occurrence.
As we're pausing for questions, just a friendly reminder that you can type your question into the Q&A panel within the WebEx interface. This can be accessed from the control dock and selecting the question mark icon to launch that Q&A panel. Again, we are pausing to address questions that have been typed into that panel. Thank you.
There you go. Okay. Well, let's move forward. Ken? Okay. Getting a couple of questions about accommodations and additions that might be made for English language learners. So I'll try to address those as we go through. I think there's a place coming up fairly soon to talk about that. Okay, so let's get back to talking about decision areas that need to be done within schools prior to actually giving a test. And Smarter Balanced folks have, kind of the responsibility up to the point that the test is out there, but they probably have a need to set things up so the test works well once it's in the testing environment. So things like school, teacher, and student identification need to be done locally, but decisions related to them need to be made systemically. Another example is setting up a testing environment. I'll jump into that for just a split second. It's really easy to create a good test that will give you invalid scores if it's administered in the wrong circumstances. So the testing environment, particularly for a technology-based test, is really important to specify for the schools that will eventually be using the system.
So for at home, always. Okay.
So for instance, easy things like covering materials in the computer lab that might contain answers are probably fairly straightforward. Slightly less straightforward is to use the testing space only for testing during the test. And the reason I mention this one specifically is that it's pretty easy to get multiple demands on technology in a school while testing is going on. And it can be very distracting for students who are working on a test in a space if there's another group of kids using another set of computers in the same space to do a programming project or a research project. So it's really important to keep the space sacrosanct for testing during the test. And that's probably one of the most difficult things to do, but it's one of the most important things to do to ensure the validity of scores for the students who are testing. If possible, establishing separated workspaces, separate carrels, would be very much advised. And just the setup of a computer lab isn't always necessarily the best setup for a test. I worked with a school once that had all of its computers in the computer lab backed to windows that looked out over a very nice scene, and it was really easy for students to get distracted. So, establishing requirements for the testing space within the school is something that Smarter Balanced will probably want to do. Okay, that's enough about the testing environment. There's an aspect of teacher training that kind of goes along with this, an aspect of proctor training that kind of goes along with this. We don't need to get too involved in those right now, but there are a series of questions that need to be addressed related to who has what training. And a lot of those need to be addressed at the Smarter Balanced level, because if you end up addressing them at the state level or the local school level, you can end up with tests that aren't comparable across the system. Okay, that's enough about school stuff. Okay, let's talk about, oops, what did I do? About test administration just briefly. During the test administrating process itself, there are a couple things that need to be done. So for instance, making it easy for the proctor to do student verification. In a lot of cases, even though the proctor works in the same school as the students, they won't know all the students. So identifying a process that enables student verification to be successful is quite good and needed in this case, because as we start to move into slightly higher stakes tests, it's real important to make sure that the student taking a particular test is the student you think they are. Okay, let's go on. There are a lot of things that we could talk about test administration, but you guys have better things to do with your life than hang around here all day. So let's talk a little bit about actually administering a test to a student. And let's start with the application of the blueprint to a student. There are a ton of ways of applying a blueprint to an adaptive test. Very, very simplest way is to create a multi-stage test, so that during the different stages of the test, you can control the content very well. And what a multi-stage test means is that there are a set of items in a particular difficulty range that are administered first. Based on the performance of the student in that block of items, you administer one of several predetermined blocks of items second. And then depending on the performance in that second block, you may go on to multiple other blocks where each block is predetermined, so you can control content extremely, extremely closely with this kind of design. The bad thing about it is that it's not nearly as efficient as a design that uses item by item adaptive selection. And there are several procedures that mentioned on this page that talk about how you might apply a blueprint, where the blueprint has content weights and item style weights and possibly cognitive complexity weights to the test itself. Probably the easiest of these three approaches is the one that I made up a bunch of years ago with Tony Zera, to simply administer the item from the content block, the content cell, and in this case it would be a cell like content by item style, by cognitive complexity, that would improve the content weights the best. So you have a set of optimal content weights, and at each stage of the test, you administer an item that improves those content weights for the observed test as much as possible. So that's the simple approach. some researchers at ETS came up with a very nice, elegant solution for giving and updating weights for each constraint, so that the overall constraint structure is well fit at any point during an adaptive test. The only reason I'm bringing these up is to make it pretty clear that, you know, regardless of how much control you want in the content and the item styles for an adaptive test, you can probably apply the blueprint in a way that gives you that control. That having been said, you probably want enough looseness, for lack of a better technical term, so that a student isn't so constrained that they will see a certain kind of test based on how they're performing. And what I mean by that is that you can easily constrain things so that a student will end up having to see an extremely hard item, even though they're not performing very well. So you want the constraints to be loose enough so that each student gets a test that fits them well. Okay, so if the option is to give the student a test that fits them well, or fits your idea of what a perfect test should be, you might want to err on the side of the student. Okay. All right. As you go through the test, you select items. One of the things that's on the screen that a lot of folks don't say is check for effort. It's real easy for a test that has reasonably high stakes systemically to be viewed as a very low stakes test for an individual student. So we all know the student who sits in a test and says, why am I here? And it's real easy for them to give less than their optimal effort, which kind of ruins the validity of the test for that individual student and causes us to make bad educational decisions for that student after the test is given. So there are a couple ways for checking on student effort, including putting in test questions that are quite easy, so that it's clear that a student isn't giving best effort if they miss an extremely easy question that they should commonly get right. You can also check for speed of response. If a student is answering a question that involves reading a 500-word passage in 4 seconds, either you're testing Evelyn Wood, or it's very likely that the student isn't responding to the question. Okay. Let me set just a little bit to talk about subscores at this point. I was talking about updating item selection based on the student's current achievement level, which is commonly called theta hat for those of you folks who aren't psychometricians. But when you update the item selection based on a student's current achievement level, you're using all the information that you have up to this point to select the next best item for the student to take within the constraints. Commonly, there is one overall achievement level that is used for selecting all the items in an adaptive test. It doesn't have to be that way, but commonly that is done. And the reason that is done is that commonly we're using a unidimensional item response model, which suggests that there is one overall achievement level for the student that reflects their responses and influences their responses to all the questions that are being answered. I'll give you a model for doing something slightly differently later on, but right now let's stay with that. Most of the time, a single achievement level is used for selecting all of the items within a test. Even though a student might be taking a math test, they're doing slightly better in geometry than they are in algebra. They will see items of a common difficulty in both of those content areas. Okay, let's talk about selecting the next item just for a split second. And as we move into the development of a new test with stakes that might be viewed as pretty high for an adaptive test in an educational setting, one of the issues becomes cheating, and another of the issues becomes stuff that isn't quite cheating but changes the characteristics of an item. So for instance, if you guys choose an item response model that has varying degrees of information, varying degrees of discriminatory power from one item to the next, adaptive testing systems are prone to administering the most informative item at the mean of the distribution quite a lot. And what I mean by this is that, you know, with an ill-structured adaptive test, you might end up administering the most informative item at the mean of student performance in the grade to every student that takes the test. And you wouldn't want to do that. And the reason you wouldn't want to do that is that even if students aren't trying to cheat, if every student sees the same item as the initial item in the test, it's going to be extremely hard for them to avoid giving information about that item to other students who are taking the test later. You know, they might not want to cheat, but they will most likely mention an item that everybody has seen. So there are a lot of ways of controlling item exposure so that you reduce item exposure to a reasonable percentage of the students taking the test, and you increase item usage of the items that might be used a little bit less. Becky Hedder and Brad Simpson came up with a procedure for applying exposure control weights to each item during the process of an adaptive test. And it's a lovely, elegant solution, which I wouldn't recommend because it's really difficult to administer. You basically have to perform a series of simulations every time you want to change an item pool. So it's not real user-friendly. Tony Zera and I came up with a procedure that allows the use of a small pond of similar items drawn from a larger pool of items that's used for the test. So you end up with a small group, let's say 20 candidate items, any of which could be used as the next item that a student sees. And then you choose from that pool, that small pond of items, randomly to allow better coverage of the item pool, allow any one item to be seen less by students. And in the original design, we talked about randomly choosing from the item pond. Excuse me. If you had the real-time data available, what I would actually suggest is that you choose the item in the pond.
I checked the one in your pool. You mailed it. Okay. Good.
Okay.
Sure. Okay. Bye.
All right. What I would currently suggest related to using a pond, if you had the real-time data available, is that you choose the item that has been used the least from the pond. That doesn't denigrate your measurement because all the items have been chosen to be in the pond, and it improves item usage and decreases item exposure. So there are a lot of procedures out there that are useful for controlling item exposure, and you'll definitely want to choose a good one to make the system work well. Okay. Okay. Somebody just asked the question, what does identify previously used items refer to? Commonly in a test that's designed for use in the schools, you might allow a school to give more than one test to a student. And this happens for two reasons. First reason is if there is a disaster, the first time the student is taking a test, they get 2/3 of the way through the test, and suddenly fire alarm goes off, or something happens that a student gets sick, something happens that causes the student not to be able to complete the test at that time. And there are two ways of handling this for a student. One is to restart the student at the point that they left during the next time they come back to take the test. Sometimes that's appropriate and sometimes it's not appropriate. For instance, with a fire alarm, you would probably want to start where the student left off. If the student was getting sick, you might want to consider giving the student a test that started from the beginning again. And in either of those cases, there will be a couple items out there that the student has seen before that you will probably not want to administer again. So that's section 1. Section 2 is if you just want to administer multiple tests from the same item pool. So if you want to administer a test in the fall and a test in the spring from the same item pool, you will want to be able to identify previously used items that a student has seen before, so that student will not see them again. Okay. Let me go on just a little bit. I'm getting about half the questions in chat and about half the questions in the Q&A panel, so it's interesting. Okay, and the last thing I wanted to mention just briefly is how the test is terminated. Two obvious ways are terminate the test at a maximum test length for all individual students. And that's pretty simple. That's pretty simple. There's nothing at all wrong with that. What you tend to end up with is kind of a system in which people are more comfortable because every student is ending the test at the same point. But you might end up with a system in which students in the extremes of the distribution, since they took a little longer to move to the point at which they're getting questions at their challenge level, may not have quite as much information in their scores at a particular test length. So you might want to allow those students to take a slightly longer test to get as much information as you would like for every student that's taking the test. So another way of terminating the test is setting an information level that you want for every student. And the good thing about that is that gives you a standard error for every student that is virtually identical, which means that the decisions that you're making for a high-performing student have exactly as much information available as decisions you're making for a low-performing student. Another place this tends to play out is in students that, for instance, are English language learners they're having a little trouble with the technical language in English, and so they're a little bit more inconsistent in their responses. Allowing a test to terminate with a variable test length might give them a little bit more opportunity to show what they know and can do. So that's another place where you might want to consider a variable test length. Okay. Okay. Let's get into some detail that's associated with some of the questions that have been asked. I want to talk just a little bit about measuring growth and adaptive testing. Adaptive testing gives you a shot at doing a decent job of measuring growth for individual students. And I say a shot because it's a darn difficult thing to do, to measure individual student growth. The nice thing about an adaptive test is that it provides you a little bit more information. Think back to what I was just saying about having a test that provides the same standard error for every individual student. If you have the same or quite similar standard errors for every individual student, then you should be able to measure growth as well for low-performing students as you do for students in the middle of the group, as you do for high-performing students, which is a huge advantage over a fixed-form test. It's virtually impossible for a fixed-form test to provide the same amount of information for low-performing students, middle-performing students, and high-performing students. And now that I've said that, you actually can design a fixed-form test to do just that, but it will have very weird characteristics, and you probably wouldn't use it in a classroom. Okay, so measuring growth and adaptive testing is possible, and if it's something that is of interest to you folks, which I think it is, the design that you use for the adaptive test is going to inform how accurate the growth measurement is for each student. And the accuracy of the growth measurement for each student will roll up to define how well any particular growth model is going to work within a state. So that's a really important decision that needs to be made. There are a couple of good models out there for measuring growth with an adaptive test. They're a little bit beyond the scope of this presentation, but they're out there, and I'd be happy to talk with anybody about those models if you have more interest. Okay. Move on. One of the questions that's been asked a couple times is, can you get multiple scores from an adaptive test? And the answer, the really easy answer is yes. And the question becomes how you get those scores. The most common way of getting content area scores within an adaptive test is after the test is over, each of the individual content areas that's in the test, the student will have answered a certain number of questions in that content area. Let's say 10 questions were specific to the content area of algebraic reasoning within the test that was taken. Those 10 items can be extracted from the test and used to create a particular score for that student in algebraic reasoning. So that's the straightforward way of doing it. And that can be done pretty much regardless of the scoring algorithm that's being used. Most adaptive testing that's operational these days is using maximum likelihood scoring for creating final scores. Coming up fast on the outside is EAP scoring, but that's probably not quite as appropriate for an adaptive test that is being used for student-level decision-making, or even decision-making at the school level, because it's basically a Bayesian approach. So it uses a lot of information. Maximum likelihood uses only information that is obtained on the day of test from the responses that the student gives on that day. So it's a little bit more appropriate for most educational decisions, but it's a decision that needs to be made. Let's get back to the idea of getting goal scores. So a simple way of getting goal scores: extract the items that are specific to that content area and create a score for just those items. And that's a very simple way of identifying whether a student just happened to have more knowledge in algebra than they did in geometry. It's probably not the best way of doing it, but it's a fairly straightforward way. It's being used in many adaptive tests quite well. If you're prone to look for idiosyncratic knowledge patterns, there are specific approaches that can be used to identify idiosyncratic knowledge. And let me give you a quick example. Two students in a classroom. One is more visually attuned to things, so they do really well in geometry, and one is not so visually attuned to things, so they do better in algebra. Nothing wrong with that. Happens every day. Millions of kids have different learning styles, so they become better in one aspect of math than another aspect of math. Now that's a little bit different from saying that there is a multidimensional solution, because multidimensional solutions tend to suggest that there are a cluster of traits that may be used for answering a particular question. And so they kind of require a different level of information to be seen in the data that's coming back from students. So as you're deciding on an IRT model, one of the first things you'll want to do is identify whether a multidimensional solution fits better than a unidimensional solution. And if it gives you enough more information, you'll want to use a multidimensional solution from the jump. And if you do that, then teasing out scores related to individual clusters of items becomes more straightforward. But if you find that a unidimensional model fits the data reasonably well, and so you want to use a unidimensional model, there's still going to be idiosyncratic knowledge patterns floating around in the data structure. So you may still want to use a test for idiosyncratic knowledge patterns within the course of giving the test. And I won't go through the algorithm for this, but it's fairly straightforward to administer a test in which the individual scores that you would commonly use to report a student's idiosyncratic pattern of knowledge at the end of the test, report the content scores at the end of the test, are also being used to select items during the test. It's pretty straightforward. Okay. Let's move forward just a little bit before I get everybody so bored that they leave. Let's talk about field testing just a little bit, because adaptive testing gives you an opportunity to include field test items within the CAT test. And I would recommend taking that opportunity because virtually every test that's ever been designed has suffered from having to give a field test that is separate from the operational test. Because regardless of how much you motivate students for taking a field test, it's easy for them to say, this field test doesn't count for anything. And therefore, I'm not going to give my utmost effort. So you folks have the opportunity to identify field test items that can be seeded into the operational test as the test goes on. Not for the first test, field testing, of course, but from that point on, you have the opportunity to include some field test items in the testing proper, and I would suggest doing that. It's a real good way of expanding the item bank and adding new content to the test in a way that is virtually invisible to the student and therefore gets the same kind of effort that the student is giving to every other question in the test. Okay, I don't think this is the appropriate place to talk too much about field testing, so we'll leave it at that. Okay, let's talk about some cautionary notes. A lot of adaptive testing has been done in several of your states and also beyond education in a bunch of other areas. And the first thing to mention is that adaptive testing needs to be well tuned to the environment to avoid bad tests. And I'll give you one really awful example. It used to be that when adaptive testing was a young child, folks would give an individual item to a person taking the test and use a maximum likelihood score to select the next item. And if you do this, the next item will either be the most difficult item in the pool or the easiest item in the pool because of the nature of an adaptive test. And so what we tended to find early in the process was that the jumps that a student was making in difficulty were outrageous. They would be moving from extremely easy content to extremely difficult content and back to extremely easy content within the course of a few items. And so part of the tuning mechanism is figuring out what the maximum jump that a student will see in difficulty is for the test. Because what you want to do is challenge a test, a student taking a test, but not frustrate them. So what you want is a maximum jump size that is tuned well to the test. So say a maximum jump size of maybe 1 standard deviation in student performance probably is not too jarring for the student, but will easily move them from a bad starting point to a level of challenge quite quickly. Less well known is you probably want to put a minimum on the jump size as well. And the reason you want to put a minimum on the jump size is that some students take longer to get started than others. So if a student just happens to be kind of fumbling at the beginning of the test, they're taking a little while to get going, they're not focusing well, they can miss a couple of questions at the beginning of the test that they wouldn't normally miss if they were revved up and ready to go. So including a minimum jump size allows that student to recover. So that after the test, let's say they don't do well on the first 7 or 8 questions, with a maximum jump size, that can put them fairly far below where they started. You'd want to put a minimum jump size in of, say, 1/5 of a standard deviation so the student can recover fairly well from a slow start. And that's good for students who need accommodations as well. But it's also good for just regular students who are having a difficult time getting started in the test. You don't want to penalize the student too much from having a rocky start in the test. Okay. The item pool has to be large enough to support the stakes of the test. In this case, since stakes are relatively high, you want a relatively large item pool, and you want a relatively large item pool that's deep across the range of student performance. And what I mean by that is that if you have a large item pool, but most of the items are in the middle of the difficulty range for the grade, that's probably not deep in the way that it needs to be deep. You need to have an item pool that is large enough and deep enough across the entire range of student performance that a student can take a test or possibly two tests without exhausting that portion of the item pool. You also want it to be deep enough so that you don't run into security problems. And I wanted to talk a little bit more about security, because that was the source of a couple of the questions that were asked. What's commonly seen now that wasn't seen 20 years ago? 20 years ago, we were dealing with small groups of students sharing information, making it difficult to give tests. You will be in the position where folks will be able to share information. So you get the unfortunate job of being the policeman of the world, and if it doesn't fall to Smarter Balanced, it falls to the states, and if it doesn't fall to the states, it falls to the schools. But there needs to be work done to identify security issues with the tests. And I'll give you one example. For any test that has reasonably decent stakes associated with it, there will be brain dump sites. And those of you who don't know what brain dump sites are, I'll give you the short version. A brain dump site is a site on the internet where folks can go and post content that they have seen on a particular test. They exist for virtually every certification and licensure exam. And the downside of these things is they kind of spring up at random. They're really hard to deal with, and they're kind of pervasive. So something needs to be done in identifying how the test will work, which will look for and prosecute, if necessary, the folks who are running these brain dump sites. Well, let me give you a really simple example of one brain dump site that had a really interesting model. And what they asked was for students who are taking a particular certification test to log into their brain dump site and give them, type in the last question that they took. And if you typed in the last question that you took, they would give you what their score was. Your score was on the test, which was, complete baloney. They didn't have any access to the scores. But what that enabled them to do was collect a large set of questions that were given on this test very quickly, which they then put into a sister site, which was identified as a test prep site. So these will spring up very quickly as soon as the test is out, and it's kind of a common problem these days, but it's a game of cat and mouse where the folks stealing content get more clever about the ways they steal them, and we get more clever about the ways we defend. One of the easiest ways to defend against brain dump sites is to continually be putting in new content into the test and making sure that the item pool is large enough so that content that is stolen represents a very small percentage of the content that is available at any time. And there are a lot of different ways of doing this. You can have an item pool that rotates in and out. Some of the certification tests use item pools that rotate in every 2 weeks, every 3 months, and then rotate out, not to be used again. But it's something that's going to be a major issue, and you need to consider it, because I'm not telling you anything you don't already know, but just the sheer nature of Smarter Balanced being a test that's used in a lot of different states will cause that test to be at risk. And so you get the great joy of trying to figure out how to make your adaptive test as secure as possible while providing the best measurement possible. Okay, that's just a cautionary note. One other cautionary note is you should probably limit desire. You're going to want to put all of the new item styles in the world into this test. And you're going to want to measure every standard that exists in the Common Core. You're going to want to resist that temptation. And the reason I say that is that kind of goes back to a question that an individual asked earlier, which is, do you end up with a smaller footprint for this test? If you try to include every item style that you have, if you try to get coverage of every specific aspect of the Common Core, you'll end up with a really long test. And so what I would suggest is that you allow some of that to come naturally. So you want to include items that measure every aspect of the Common Core, at least every aspect that makes sense to measure within the adaptive test. But you probably don't want to control the blueprint of the test so much that every individual aspect of every Common Core standard is showing up on every individual's test, because that will end up being an extremely long test. So when we talk about constraints, and I'll give you an example of constraints as being, you want 10% of this test to be algebra content. You want 20% of this test to be geometry content. You also want 10% of this test to be this item style, and you want 50% of this test to be this other item style. And by doing that, you've kind of included every aspect of geometry under that geometry umbrella. If you get the constraints too much finer, you will tend to have to have a larger test, a longer test for the students, and you will tend to make it less secure. So applying a blueprint lightly, but doing everything you want to do is probably a much better place to stand. Okay. Last cautionary note, adaptive test development is never done, particularly with a test that is reasonably high stakes. The first test that you put out will have security holes in it that you don't recognize now, but you will recognize after they go out. So for instance, if you're using long reading passages with a lot of items associated with them, that's potentially a security hole. If an individual can get access to the reading passage, particularly if you're using reading passages that come from literature or come from Census Bureau materials, whatever it is you're using, those passages can be accessed fairly easily if an individual has a decent search that they're able to do. So I would recommend you expect to do additional adaptive test development after the first year, because designing an adaptive test isn't a done and done deal. It's something that needs substantial maintenance. Okay, and the last thing I wanted to say, before I go a little deeper into the questions, is that you should have fun. I mean, the development of an adaptive test, it is a bunch of work, but in its nature, it's kind of a fun activity. You get to design new item styles for getting at content that was difficult to get at before. And so there's a lot of fun to be had during the process, and I suggest you take advantage of that. I also suggest that you remember who your client is. And even though it might be tempting to say the federal government is your client, your client is actually the kids who are taking the tests. Okay, and the decisions to be made should consider the good of those students. Okay, the good of the students for whom the test is designed. And that's why I suggest that you consider a dry eye policy, and to the extent that you can make this reality. You really don't want kids crying during the test. And so to the extent that you can do whatever is in your power to reduce the number of kids that are going to be crying in Washington as a result of this test, you've probably done a good thing. Okay, you want to make a test that is challenging for every student who takes it, but not so onerous that the test is seen as a terrible task for the student. Best of all possible worlds, you'll design a test that engages the students so well that they will forget that they're taking a test and remember that they are being challenged. Okay? Because when you get to that point, you've kind of won, because kids are giving you their best effort and they're not being distracted by the fact that they're, oh my God, in a testing situation and it's terrible, or thinking, I'm not very good at tests, I'm doing really badly on this test. You want to get to the point where a student is taking a test that challenges them, takes them out of themselves a little bit, gets them past some of their issues that they've had with taking other tests in the classroom, and gets them to a place where they're doing their best for you guys. Because when you get to that point, you're getting the best information that you can get from those students, and they're not seeing it as an onerous task. So that also suggests that you might want to consider all of the constraints that you want to put on the test, and then figuring out how short you can possibly make the test. Because making the test short in kind of a rational manner is probably where you want to stand. Okay, and I think that's all of the main content that I had for you folks. I did want to go back and address some of the questions that you folks have given me in the couple minutes we have left. And if you have a terrible burning question that's still sitting out there after we're done, you can get me at this email address. Probably want to filter your questions through the Smarter Balanced folks, but if you have a question that you feel an urge to ask me, I am on my way to being a highly paid external consultant as soon as I finish up work at NWEA. So I'll be happy to answer questions. First one's free, second one costs you a fortune. Okay. You know, it's really bad to do jokes when everybody's muted because you can't tell whether they work or not. Okay. Let me go through the questions that were asked and see if I can tease out a few more questions that might not have been asked. One of the questions that was asked was, it appears that the beginning questions affect the score more than the later questions. Can you help me respond to this concern? The answer to that question is they don't really. Every question is being used to design the test, but once the test is over, questions that were seen at the beginning, questions that were seen at the end, both of those contribute to the final score exactly the same amount. Now, the reason why people sometimes say that it appears that the beginning questions affect the score more than the later questions is that they see that the test being designed based on the student's initial answers. So initially, I'm having some trouble getting revved up for the test, so I'm getting easier and easier questions. But the student can still recover regardless of what they do at the beginning of the test. So the first 3 test questions, the last 3 test questions, both count exactly the same in terms of the student's scores, given that they have the same IRT characteristics. So it's not the case that the first test questions count more in the score than the last test questions. In fact, it's exactly the opposite. All of the test questions that are seen count exactly the same toward the student's final score. Someone asked a question that said, I believe that security is better in an adaptive test. What are the challenges to computer adaptive test security? We talked a little bit about this. It is the case that security in an adaptive test will almost always be better than security in a fixed form test. Fixed form tests are notoriously prone to compromise. Fixed form tests that aren't being given at the same instant to all of the individuals who will be seeing them are very prone to compromise. And what is called time zone compromise is very likely to occur with a fixed form test. You have a fixed form test that's being administered at 9 o'clock in the morning on the East Coast and 9 o'clock in the morning on the West Coast. And it's a test of relatively high stakes. It's really easy for the folks who see the test at 9 o'clock in the morning on the East Coast to give information, including the entire test form, to folks on the West Coast. So an adaptive test provides you with a layer of security for a test that is going to be given across a period of time that a fixed form test can never match. But that having been said, there is still a substantial amount of compromise possible in an adaptive test. And probably the worst example of this that I remember seeing is when the GRE went adaptive the very first time. They had a reasonably small item pool that they were using, and a very nice test prep vendor stole all the items by sending in individuals one at a time to the test, and they got a substantial percentage of the item pool. But then they actually talked to ETS, who is the test vendor, and said, hey, we were able to steal a huge number of your questions. We don't plan to use them, but you should know that your test is at risk from folks less scrupulous than us. That was probably the example of a very high stakes test, the GRE, going live with too small a pool of items, and it was fairly straightforward for an agency to to send in folks to take the test to steal a fairly substantial percentage of the item pool. That's why most folks recommend item pools that are larger than you would expect these days. Most certification and licensure exams that are large-scale exams tend to use pools that are over 2,000 items in length, in depth. The agency that I've worked with for a long time, NWA, uses item pools that are several thousand items deep for their tests, even though it tends to be a fairly lower stakes test. So a lot to consider in creating an adaptive test. Let me ask a couple questions. There are a couple of questions asked about accommodations. Accommodations in an adaptive test for many students can work exactly the same as accommodations in a fixed form test. So for instance, if a student needs a reader, that can be implemented in a couple ways in an adaptive test, but an easy way of doing it is allowing the student to have a reader on the adaptive test. So you can have high-tech solutions, low-tech solutions that allow you to use the same accommodations with an adaptive test that you use in a fixed form test for the most part. There are some accommodations that are difficult to use within an adaptive test without being very careful about the item pool. For instance, a Braille screen or a Braille reader can be difficult to use with an adaptive test unless you make sure that all the items that are being seen by the student are appropriate to use with a Braille reader. So that's an example of a difficult accommodation to use within an adaptive test. For students who are English as a second language students, many of the things that you would use with a normal test, you would use with the adaptive test. So you would probably make sure that the student was reasonably fluent in English before allowing them to take the test in English. But the translation, the good translation approaches that can be used with a fixed form test can also be used with an adaptive test. It's a little bit trickier because you have to translate more items, but they can definitely be used. Let me see. I am running out of time, and I don't want to use up all the time with letting the smarter balanced folks say goodbye. Well, let me answer one question about unidimensionality and multidimensionality that came up. Unidimensionality and multidimensionality is really kind of an empirical question, and it's one of those things that you need to do early in the process to identify whether you can use a unidimensional solution with your tests or whether you need a multidimensional solution. The good thing is there are lots of decent tests out there that can be used early in the process, especially doing field testing with fixed form tests should allow you to use a lot of nice factor analytic approaches to and structural equation approaches to seeing whether there is evidence of consistent multidimensionality in the test. And that should enable you to decide early on whether a unidimensional model or a multidimensional model should be used. That having been said, a lot of folks ask questions about the multidimensionality of the content space. In mathematics, for instance, you have algebra and geometry, and you have numeration, you have a lot of different things. Isn't that kind of prima facie evidence that there is multidimensionality in the content area? And the answer is no, actually. you go from a very rich content domain to how student answers questions on the test. And the dimensionality isn't in the content domain, at least the dimensionality that we use to identify an IRT model. That dimensionality is in the responses of students to the field test items, the responses of students to operational adaptive tests. So what you want to do is take into account the content richness in defining the blueprint for the test. Once you have that blueprint for the test, then you have an empirical question to answer, whether or not the data that you're getting back from the test is multidimensional or unidimensional. And that's a common misunderstanding that's out there. And because we use the word multidimensional in many ways. Is the content multidimensional? Certainly. Is the response space multidimensional? It's an empirical question, and we need to ask that question in order to develop a good adaptive test. With that, I think I've exhausted my time, so if anyone from SBAC wants to put an end to this thing, I will allow you to do that.
Thank you, Gage.